Okay, we're going to look at trigonometric functions using radian measure instead of degrees. So first we have to figure out what a radian is. So definition is basically a radian is a unit of measure for angles. 1 radian is the angle created by moving 1 radius of arc length around the outside of a circle. So this is the diagram that you'd be looking at. Okay, so 1 radius of arc length around the circle. So this radius here, if you move that around the circumference of the circle, that creates 1 radian of an angle. Okay? Since the circumference of the circle is c equals 2 pi r, there are 2 pi radii around a circle. So 2 pi, well, pi is 3.14. Okay, so 2 pi radians, or radii, around a circle means that there are about 6.28 of these radii around a circle. So in half a circle, you'd have a little bit more than 3 of those little pieces of pi. Okay, and the other half, you'd have another 3, so about 6.28 pieces of pi around the circle. That's how that would look. So that's what a radian is. Okay, and this means that 2 pi radians as an angle measure is equal to 360 degrees. And easier to look at pi radians then. So if 2 pi is 360, then 1 pi radian is 180 degrees. So we're going to write rads as radians for the next slides. Okay. Now, we want to convert degrees to radians and see what that looks like. Okay, so let's see here. So the degree to radian conversion table is going to look like this. Well, we're going to start off with degrees. Okay, and we're going to use the angles that we've seen before that are from our special triangles, which we'll look at later on. So we're going to start off with 0, 30, 45, 60. So we're going to go in multiples of 30. So 0, 30, 60, 90, 120, 150, and 180. So those are multiples of 30, right? And we're also going to go in 45. So 0, 45, 90, 135, and 180. So these are all angles that we would have seen from our special triangles. And we're going to go do the second half of the circle in this other table here. So 0 degrees, well, how many radians, how many radiuses are there around a circle in 0 degrees? Well, there are 0. Okay? Now, what about in 45 degrees? Well, we already looked at the one that was 180 was equal to pi. Okay, so if 180 equals pi radians, then 90 is half that. It's got to be pi over 2. And 45 is half of pi over 2, so that would be pi over 4. Well, 30, what fraction of 180 is that? So 30 out of 180 reduces to 1/6. So that would be 1/6 pi. So this is what you get for converting radians or degrees to radians for the first 180 degrees. So 0, pi is 180, half of that is 90, which is pi over 2, half of that is pi over 4, which is 45 degrees, and then 3 pi over 4 would be 135. Okay, and then we've got pi over 6 is 1/6 of it. Okay, 2/6 would be 60 degrees, and 2/6 reduces to 1/3. Okay, and then 3/6 would be pi over 9, or it would be 90 degrees. So 3/6 is pi over 2, because 3 over 6 reduces to 1/2. Okay, and then 4/6. Well, 4/6 is reduces to 2 over 3. Okay, so each time we're going up by 1/6 of 180, Because 30, 60, 90, 120, they're all going up by 1/6 of 180, or 30 degrees. Okay, and so on. And then we get the second half of the table, looks like this. So you should be able to develop this table just by looking at what you already know from trigonometry with degrees, with this circle. Okay? So you take this circle, you measure off 30 degrees, 45, 60, 90, and so on all the way around. You should be able to write down the conversions, and you should see that this is 1/6 of pi. 2/6, 3/6, 4/6, 5/6. Okay? And this is 1/4 of pi. 2/4, 3/4 pi. And then going beyond here is the same thing. So if that's 4/4, then that's 5/4, 6/4, 7/4, and you're just reducing the fractions to get these numbers. Okay? So that's what you have for converting degrees to radians. It's worth pausing the video and trying to make sure that you understand this, okay, before you go on. All right. Now we do have a formula for this. So if we're not converting nice angles, so we want to convert radians to degrees, or degrees to radians. Well, we use one thing that we know here. We know that pi radians equals 180 degrees. We know that 2 pi radians equals 360, but this is a reduced conversion. Okay, so we can write pi radians equals 180. So if we want 1 radian, well, we're just going to divide both sides by pi. And if you divide both sides by pi, you get 1 radian equals pi over 180, or sorry, 180 over pi in degrees. Okay? So then if you want to convert x radians to degrees, you do x times both sides. So x radians equals x times 180 divided by pi, and that's your conversion to degrees. Okay, so an example would be here. 2 radians. Well, 2 is the x. You're going to go 2 times this. So 1 radian is this many degrees. So 2 radians is 180, 2 times 180 over pi degrees. 2 times 180 is 360. If you divide this, you get approximately 114.6 degrees is 2 radians. Quite a bit bigger number. Now, if you want to go degrees to radians, just write that first formula that we had the other way. Okay? So 180 degrees equals pi radians. We know that one. Divide both sides by 180. And this is a conversion for 1 degree equals pi over 180 radians, which is pretty small. So if you want to know what x degrees is, well, you multiply both sides by x. So x degrees is x times pi over 180. Okay? An example for that would be if you wanted to convert 17 degrees to radians. Well, 17 is the x, so 17 times pi divided by 180 is approximately 0.2967 radians. So 17 degrees is about 0.2967 radii of arc length. Well, that's smaller than 1 radius of arc length. It's almost 1/4 of a radius of arc length. Okay? So that's what that means. We're going to look at a couple of examples now. First example is going to be textbook here, page 321, number 5. Let's take a look at this. So number 5 right here. So maybe you want to pause the video and take a look at this question, see if you can try it yourself, and then play it as you see it. So determine the measure of central angle, so it's at the center of the circle, that is formed by an arc length of 5 centimeters in a circle with radius 2.5 centimeters. Okay? And you want the answer in both radians and degrees correct to 1 decimal place. All right, let's take a look at this. Okay, so the arc length is 5 centimeters. That's what we know. and the radius is 2.5 centimeters. And so we want to know what the angle is in radians and what the angle is in degrees. That's what we want to know. Okay, so the solution. So by definition, one radius of arc length forms an angle of 1 radian. Okay, so 1 radius of arc length. Well, the arc length is 5 centimeters. The radius is 2.5. So right away you should be able to see that that is, the arc length is 2 radii. So that should be 2 radians. But here is a formula for you. Okay, so in radians, the angle equals the arc length divided by the radius. This tells you how many radii there are in that arc length. And that is, by definition, the angle in radians. The number of radii in an arc length tells you the angle in radians. Okay, so 5 is the arc length divided by 2.5. Angle is 2 radians. There we go. In degrees, well, we can just convert that, right? So the angle equals 2 times pi over 180, just like we did before. And we got the angle of 114.6 degrees. Okay, so this is using our conversion formulas. Okay, and B was determine the arc length. Okay, determine the arc length of the circle in part A if the central angle is 200 degrees. So now you're given the angle and you want to figure the arc length. Right. So what if the angle is 200 degrees? The arc length would be, well, that's what we're trying to find out. Okay? So the angle in radians is going to be 200 degrees times pi over 180. That's our conversion to go from degrees to radians. So it's 3.49 radians. So that tells us that there are 3.49 radii in 200 degrees. Now we know how long one radius is. It's 2.5 centimeters. So the arc length is going to be the radius times the angle in rads, not in degrees, right? So the radius, and the angle tells you the number of radii when you do it in rads. So 2.5 centimeters times 3.49 is 8.725 centimeters. So that's the arc length in 200 degrees. Okay? We're going to stop here, and I'm going to do a couple more examples in the next video.